All right, here's try it 3.7, a relatively challenging problem, I guess. I'm given this function, and I'm asked to evaluate f of negative I. Well, that doesn't sound too bad, because f of x is this thing, so f of negative I, no problem. Just copy this thing, and by this thing, I mean this thing, but change all the x's into negative i's. So instead of x plus 1, I guess I would write negative I plus 1. That felt weird, but okay. And instead of x minus 4, I would write minus 4. Instead of x minus 4, I'd write negative I minus 4 and get to here. And this is good in that this is what comes out of the machine when you put this in, but this can be simplified. The way I would simplify this is I could think about this as dividing complex numbers. Okay, this doesn't look like complex numbers because negative I plus 1 is not in standard form. But I could say this is 1 minus I, right? Negative I plus 1 is the same as 1 plus negative I. But 1 plus negative I is just 1 minus I. And down in the denominator here, I could have, by the same logic, negative 4 minus I. And now at least it looks like complex numbers, and having it look like complex numbers will make it easier for me to divide them. Because I remember how to divide complex numbers. That's that thing where I first got to figure out the conjugate of the denominator and multiply the top and the bottom of this fraction by that conjugate. So what I'm going to do is I'm going to multiply this by negative 4 plus I over negative 4 plus I. Note, not 4 plus I, negative 4 plus I. You do not change the sign on the real part. You only change the sign on the imaginary part. You change the sign in between the a and the b and a plus bi. This is what you're going to multiply by. And note, since I'm doing it to the top and the bottom of the fraction, I'm not changing the value of the fraction. So what I come up with over here will be the same as what I have in green here, which is what I have here. So let's FOIL things out. 1 times negative 4 is negative 4. Negative I times negative 4 is positive 4i. 1 times I is just I, or 1i, I guess, if you want to write it like that. And negative I times I is negative I squared. And down in the denominator, this should end up just being a real number if I did things right, because I'm multiplying a number by its complex conjugate. And in fact, it will. Negative 4 times negative 4 is 16. Negative 4 times positive I is negative 4i. However, negative I times negative 4 is positive 4i. And you might get to the point where you don't even write these anymore. You just recognize that those terms are always going to cancel each other out. Fine. We're still learning this. I'm going to keep writing it. Negative I times positive I, well, negative times a positive is a negative. And I times I is I squared. That gets me here. On the top, I got negative I squared. Well, I squared is negative 1. So the negative of negative 1 is positive 1. So this thing right here is really a positive 1. And this positive 1 and this negative 4 nets out to negative 3. And I have 4i and 1 more I gives me 5i. Down in the bottom, I got 16. The negative 4i and the positive 4i cancel out. And again, this is negative negative 1, aka positive 1. 16 and 1 more is 17. That gets me here. And you're done, you're pretty happy. Well, you're not exactly done. If you left this as your answer, your teacher would probably be pretty proud of you, but might not give you full credit because this is not done. The reason this is not done is it's not a complex number. I would like the quotient, well, I would like the quotient of two complex numbers right here to be equal to a complex number. Complex numbers must be written in the form a plus bi. So I would have to rewrite this as negative 3/17 plus 5/17 of I. And this right here is what I would call my final simplified answer.